This video is for Notes 8-2. For Notes 8-2, we're starting by working problems 2 and 3 on the Bell Work page on the very front of your notes packet. So they ask us to graph the following two variable inequalities. The first one, we start up at 3 because that's our b value. Our slope is in Ninja 1. So we start at 3 and then up one, right one, up one, right one. Our line is going to be dashed because we do not have the line under the inequality. And then for our shading, if we ignore the x, y is everything greater than 3. Greater than 3 on the y-axis is everything above 3. So we shade above our line. They ask us to give a point that is a solution. So if we went like here, something very clearly within our shaded area, that would be the point -3, positive 1, 2, 3, 4, 5, 6. As long as it is in that green shaded area, is not on the line, and is not in the white space, then it would be a solution. Problem 3, in order to graph, we need to solve for y first, so I move x to the other side. When I move x, excuse me, I make sure I bring down the -2y. I also make sure that because these are not like terms, I simply rewrite them. I need to divide everything by a -2. Because I am dividing by a negative, my inequality symbol is going to flip. X divided by 2 is 1/2 x. -8 divided by -2 is a positive 4. So I'm going to start up at 4. Use a slope of up 1, right 2, up 1, right 2, up 1, right 2. Make sure you're using your final answer inequality symbol. This one would be a solid line because it has the line underneath to show us that it's solid. And then my shading, y is less than or equal to 4. Less than 4 would be anything underneath 4, so we shade underneath. A point that is clearly in the solution, we could go all the way out here to 10, -10. Anything on the line or in the blue area would be a solution. Anything in the white would not be a solution. Keep in mind, too, for problem 2, the first one that we did over here, this line is dashed, so the line would not be a solution. This line is solid, so something on the line would be a solution. So remember our steps, we solve for y when necessary. We graph the line, either solid if it has the lines under the inequality, or dashed if it doesn't, and then determine the shaded region. So for problem 1, we need to solve for y like we did on the Bell Work. I move x to the other side. So -3y is greater than or equal to -x minus 6. Divide everything by a -3. So y is, flip my sign because I divided by a negative, 1/3 x plus 2. This is going to be a solid line because of that tiny little line right there. My m value is with x and my y-intercept follows. The rest of these I can't determine if it's a solution until I graph it. So I go up to 2 on the y-axis and then go down 1, right 3, down 1, right 3, down 1, right 3. We said that we will have a solid line. And then I need to determine my shading. Oops. For my shading, y is less than or equal to 2. Less than 2 would be underneath 2. Anything on the y-axis less than 2 would be under 2. So we shade underneath. So the point -2, 6 up here, we'll call this point A. Point A is not a solution because it's not in the shading. The point 5, 6 is not a solution because that is not in the shading. Oh, shucks. Okay, I apologize. I did the wrong graph. So my b value of 2 was correct, but I was supposed to go up 1, right? 3. Still a solid line, still shading underneath. So the point -2, 6 is still up here. And 5, 6 still is not in the shaded area. Okay. Problem 2. We're going to solve for y again. So move 3x to the other side. 2y is greater than -3x plus 6. Divide by 2. This time, because we're dividing by a positive, we leave our sign the same because it doesn't change. The only time it changes is when you multiply or divide by a negative, and that did not happen here. So our y-intercept is at 0, 3, and then we go down 3 right 2. This time for real we're going negative. This line will be dashed because there's no line under the inequality. So anything on the line is not a part of my solution. And then for my shading, y is greater than 3. Things greater than 3 are 4, 5, 6, 7, 8, 9, 10 above the line, so I shade everything above the line. So is the point -5, 6 a solution? The answer would be no because it's not in the shading. The point 0, 0, nope, not in shading. So again, once you graph, you are just looking for your shaded area. Now the next two are two special cases. First, we have y is greater than 3. So this is going to be a Hoy type of line. We go to 3 on the y-axis. The h in Hoy tells us it's going to be horizontal. Our inequality symbol tells us it's going to be dashed. For our shading, y is greater than 3. Greater than 3 is everything above 3. So all of this is included in my solution set. The point 5, 6 is up here. That is in my solution set. So yes, because it's in my shaded area. The point 0, 0 down there is not. So it's either yes because it's in your shading area or no because it's not in your shading area. Problem 4 has an x, so it would be a vux, meaning we have a vertical line starting at -4. This vertical line will be a solid line because there is a line under the inequality. X is everything less than -4, less than -4. Now this time we're specifically looking at the x-axis. Less than -4 would be more negative, and that would go to the left. So this is the only time that you do not look at your x-axis. I'm sorry, this is the only time you do look at your x. It's the only time you don't look at y. The point -2, 3 is not a solution because it's not in the shaded area. The point 0, 0 is also not in the shaded area. Problem 5 is asking us which of the following would be a solution to the inequality. And so I need to solve for y. I'm going to move 3x to the other side. So -3x minus 2 is less than -y. Divide everything by a -1. So 3x plus 2 is greater than y. We can also rewrite this if the direction does not help you. We can graph it first. So we start up at 2, and we go up 3, right 1, up 3, right 1. This is going to be a dashed line because there is no line under the inequality symbol. And our shading 2 is greater than y. We could also say y is less than 2. Less than 2 would be 1, 0, and anything that is negative. So anything under the line would be in my solution set. So my points, negative 2, 0, is not in my solution set. 4, 8 would be in my solution set. Negative 6, negative 2 would not be in my solution set. 8, 3 would be in my solution set. And 1, 5 is on the line, but because the line is dashed, it is not a part of my solution set.